Hi everyone, so in this video we're going to be talking about slope and how to use it to graph. So first off, slope, you've probably heard it before as rise over run or the change in y over the change in x, but essentially it just measures how steep a line is, right? A positive slope, when you look at it from left to right, is going upwards. A negative slope, when you look at it from left to right, is going downwards. The higher the slope, the more steep it is. Okay. So first off, we're just going to be looking at some graphs and seeing what the slope actually is. So if we look at example 1, we have a line on there, and the first thing that we're going to do is we are going to pick any 2 points on this line, right? Specifically, we want to pick any 2 nice points that we can easily tell what those points are. All right, so I'm going to pick 0, -2, and 2, 1 as my 2 points. If you pick 2 different points, it won't matter at all. You're going to get to the exact same slope. So just whatever 2 points you see, use those. So we already said slope is rise over run. So to find slope, all we're going to have to do is we are going to see how high this is going to get to the next point. So left to right, we're going to see how much does it rise, so how high does it need to go to get to the next point. So starting at this point on the left, we would have to go up 1, 2, 3, and if you can see, we are now on the same kind of level as that next point. So that means we had to go up 3 to get to the next point. That's part of our slope. That is our rise portion. The run portion is how far do you need to go over. So we would have to go over 1, 2. Then we'd be on that next point. So over 2. That is it. That's our slope. All right, let's try another one. So for example 2, again, just pick any 2 points you see. I'm going to pick -2, 5, and 0, 0. Again, whatever 2 points you pick are perfectly fine. All right, so starting again left to right, we'd have to go down this time 1, 2, 3, 4, 5 to get to the same level as the next point. Now, that part's our rise, but keep in mind I said down this time. Anytime you have to go down, we're going to go ahead and make it negative. All right, let's see our run part. So to get to that point from here, we'd have to go over 1, 2. So over 2. And that's our slope. Which, it makes sense that this one's negative, because remember, from left to right, negative should mean that the line's going down, which this one is. All right, number 3. So if I pick 2 points, say -4, 0, and 0, -1, then again, left to right, we'd have to go down 1. Then we have to go over 1, 2, 3, 4. That's our slope. All right, example 4. I'm going to pick this one and this one. So we have to go up 1, 2, 3. So that's rise 3. we have to go over 1, 2, 3, 4, 5. And so 3/5 is our slope. All right, these last two are going to be a little bit weird. Specifically because if we look at this one, first off, it doesn't even have any nice points. All the points are between 4 and 5 on the x-axis, so it's hard to see where exactly they are. I'm just going to pick a couple points. That way you can get the gist of what's about to happen. Let's say we pick these. So let's say I'm going from bottom to top. I would have to go up 1, 2, 3 to get to the next point. But how far would I need to go over? Well, it's already on the point. So I would go over 0. This right here is a problem. You cannot ever divide by 0 in math. So this slope, we're going to call it undefined. Right? Which makes sense because remember, it's talking about the steepness, and the higher the number, the more steep the line is, but if it's completely vertical, well, that's kind of like, you can't really measure that anymore. Like that's perfectly vertical, so we don't really say that it's steep. All right, example 6 is going to be a little similar. So again, let's pick a couple points. So how far up or down would we have to go? Well, we'd have to go up or down 0, because it's already on the same level. But then we'd have to go over 3. This one's not a problem. 0 divided by 3 is just 0. So we have a slope of 0. Right? So just keep in mind for later that a vertical line has an undefined slope and a horizontal line has a slope of 0. Again, it kind of makes sense because if you think about the floor, you normally don't say that a flat floor is steep, right? So it's a slope of 0. All right. Another way to find slope. So you're not always going to be given a graph of it. Sometimes you're just going to be given a couple points. So instead of having to make a graph and plot these points on there and try to count, there's actually a formula for slope, and it is right here. So the m means slope. The y2, y1, x2, x1 come from your two different points. We're going to say our two different points are x1, y1. Those just stand for the x and y coordinate of that first point. And x2, y2. Again, x and y coordinate of the second point. That's where the 2 comes from. All right, so just given those 2 points, we can plug it into this formula and we'll have the slope right there for us. All right, so let's go ahead and do that. First thing I'm going to do is I am going to label our first 2 points for example 7, just so we don't get confused. So this is x1, y1, x2, y2. And then let's go ahead and plug them in. So we have m equals y2 minus y1 over x2 minus x1. y2 is 4 minus y1 is 3 over x2 is 3 minus x2 is 1. From there, it's just a matter of simplifying. So 4 minus 3 is 1, 3 minus 1 is 2, and we get our slope of 1/2. All right, let's try example 8. Example 8 is going to be very similar. This time we do just have some negatives, so we're going to have to be a little careful about those. So again, m equals y2 minus y1 over x2 minus x1. And this is x1, y1, x2, y2. So y2 is negative 2, minus y1 is 4, over x2 is negative 8, minus x1 is negative 2. So be very careful here. That's minus negative 2. If you notice, there's two negatives right there. So anytime you see that, minus a negative is really just like plus. So whenever we get there, we're just going to add those. Let's do the top first though. Negative 2 minus 4 is negative 6. And negative 8 plus 2 is also negative 6. Simplify that and we get 1. All right, number 9. So if I go ahead and label these, we have m equals y2 minus y1 over x2 minus x1. All right, y2 is 3, minus y1 is 6, over x2 is 5, minus x1 is 5, which is negative 6 over 0. And what did we say about dividing by 0? That right there was a problem. Can't do it. So we're going to say that our answer this time is that our slope is undefined. All right, before we get into actually using slope to graph an equation, we're first going to just do a really quick recap, hopefully, on solving for y. If it's not necessarily a recap, it's okay. That's why we're going over it. But you will need to be able to solve for y for these, right? So solving for y is the same thing as just solving a normal linear equation. The only difference is you're just moving around the x. You're not trying to necessarily get rid of x or anything like that. Your answer is going to have an x in it, right? So for this first one, if we want to solve for y, first thing we do is we want to move the x to the other side. Because we want y alone, so we don't need x over there. So we're going to have 3y equals negative 4x plus 21. Last, we'd have to divide by 3. Now just be very careful, because whenever we divide this right side by 3, you need to divide everything by 3. As in, both terms are about to be divided by 3. So negative 4x divided by 3, well, 4 doesn't divide by 3, so we can just leave that as negative 4/3 x. 21 divided by 3, though, that one's nice, so plus 7. And y is solved for. All right, let's try again on number 11. So again, move the x first. So minus 5x from both sides. We get negative 2y equals negative 5x plus 10. Divide both sides by negative 2. So we get y equals, again, negative 5 divided by negative 2. 5 doesn't divide by 2, but we can cancel those negatives out because negative divided by negative is a positive. So it'd be 5 halves x. And then 10 divided by negative 2 is negative 5. So y is solved for. All right, one more. Again, start by moving the x. So we get 6y equals negative x plus 12. Then divide both sides by 6. So we get y equals negative 1/6 x plus 2. All right, with all that said, here's how we are actually going to use slope to start graphing lines. So sloped intercept form is y equals mx plus b. The reason it's called slope intercept form is because it gives you two very important pieces of information. M, the number with x, is the slope. So as long as y is solved for and it's in this form, it just tells you the slope right away. B is the y-intercept, specifically 0, b would be the y-intercept. So again, it just tells you that information. All right, here's how we're going to use it. The slope tells us how to get from one point to another. If you remember, that's how we started this video, was we counted up and over or down and over to be able to get from one point to another. The slope tells us exactly how much we need to go up or down, how much we need to go left or right. The problem is we need a starting point. We need some place to start, that way we can count and get to the next point. That's where the y-intercept comes in. That's a point that's given to us just for free, so we can start there and then count using the slope to get to the next point. Okay, so here's how that's going to work. For number 13, first off, it's already in the form we want, so that is perfect. We don't have to do any extra work there. So we can read off the slope and the y-intercept. The slope is 3/2 because it's the number with x. The y-intercept is 0, negative 1, the number that's not with x. All right, we're always going to start with the y-intercept. In this case, our y-intercept is 0, negative 1, so we're going to go ahead and plot that on our graph. Next, we're going to use the slope to find any more points that we need. All right? For this notes video, I'm going to say that we're going to find 3 points for all of these, but depending on the homework, give however many points it needs. Okay, so our slope is 3/2, and what that really means is we are going to go up 3, because that top part is the rise, and then right 2, because that bottom part is the run. So from our y-intercept, we're going to count up 1, 2, 3, and then right 1, 2. That is going to be our second point. If we want a third point, we just do that again from our second point. So we can go up again 3, right 2, and that could give us a third point. If we wanted to go in the other direction, we could even do that by doing the exact opposite of both. As in, instead of up and right, we could go down and left, and it would still give us points on the same line. As in, we could go down 1, 2, 3, left 1, 2, and that is another point on that same exact line. Now, at this point, please make sure that these do in fact line up. So at this point, they should form a straight line that you can draw a line through. So if we go ahead and draw that line, put arrows on both ends because it doesn't actually end, we are done. All right, let's look at number 14. For number 14, the biggest difference right away is that y is not solved for. So down here, first thing we're going to do is we're going to solve for y. All right, to do that, the first thing we're going to move is this constant to the other side. So we got 3y equals 2x minus 12. Then we can go ahead and divide both sides by 3. So we get y equals, don't forget we got to divide both by 3. So that'd be 2/3 x minus 4. Once we have it back in that form, it gives us our slope and intercept. So our slope is 2/3, our y-intercept is 0, -4. All right, let's go ahead and start with the y-intercept. So 0, -4 is a point right down here. And from there, we can go up to over 3 to get to our next point. So up 1, 2, right 1, 2, 3. That gives us our next point. Again, that's just because the top is our rise, the bottom is our run. If we want a third point, we go ahead and do that again. So up 1, 2, right 1, 2, 3. There's our third point. And I always recommend doing at least 3 points for a line, just because if you make a mistake with one of those first 2 points, you won't really be able to tell. But if you put a third one and they don't all 3 line up, then you might be able to see that you did something wrong. All right, with that said, we go ahead and draw the line through these since they do in fact line up, and we are done. All right, so that this video doesn't get too long, I am going to stop this one here. There will be a part 2 that will be linked in the notes. So watch the part 2 for some more examples and a couple more things about slope and graphing. So I will see you in part 2.